Alrighty guys, welcome back. So this is going to be the last video of the term. Let me just take this time to say thank you for all those that tuned in to some of the videos. I really hope that they did help you along the way. Best of luck if you have not taken your final exam yet on the final. But moving on, now I apologize I didn't get this video out yesterday like I planned, as you may be able to hear. A little bit under the weather. But of course the march must go on. So looking at a few problems here from our Navagate math assessment. The first one here that we missed, I believe it was number 5. Yeah, number 5 was a problem missed most often. Only 45% of you folks got this one correct. And it says we want to write this decimal as a fraction or a mixed number. And we have negative 0.33. Okay, so we have negative 0.33. So remember, if you are given some sort of decimal and your goal is to go to a fraction, what we need to do is we need to kind of play with this decimal point here. And what we're going to do here to start off is we want to see how many places do we need to move this decimal place to the right until all of the numbers until all of these numbers are now going to be in front of the decimal place, right? So we want to move this decimal to the right a specific amount of times until all of these numbers are in front of the decimal place. So taking our decimal, we can move it once to the right, and notice that we still have one digit to the right of the decimal. So now we would have to move it a second time to the right. And now all of our digits here are to the left of this new decimal place, right? So we're now looking at 33 point, and if it helps, you could add another 0 over here, 33.0, all right? Now do not forget about this negative sign out here. I have a sneaking suspicion that that is what a lot of folks may have forgotten when they did this problem, okay? So remember, we moved this decimal place 2 places to the right, and now we are looking at 33.0, and that would be a negative 33.0. All right, but because we moved this decimal place 2 spots to the right, we need to account for that, and we need to divide by 100. Okay, so if you want to think about it, right, we just move this 2 spots to the right. In other words, if you look at the number you're left with now, that negative 33.0, okay, that means that we're going to have this decimal place, if we wanted to move it back, it would take us 2 places to the left, once and twice to the left. And when you divide by 10, you're moving the decimal place back 1 spot. If you were to divide by 100, which is what we did, you move the decimal place back 2 spots. If you divide by 1,000, you move it 3 spots. Divided by 10,000, you move it 4 spots, so on and so forth. So the idea here, guys, is that the decimal, negative 0.33, is equivalent to negative 33.0 all over 100. Right? So basically, you move the decimal place 2 spots to the right, but then you account for that movement by dividing by 100. All right? Now, it does not say in the directions of the problem that we need to simplify this fraction. And really, if you went ahead and tried to simplify it, you would realize that we can't, in fact, simplify this fraction. So this fraction would work out just fine. Negative 33 all over 100. And that's your answer. All right, so we've got a couple more questions here we're going to take a look at, and we'll get onto those in just a second. All right, so our next problem we're going to take a look at here, guys, is number 28, this problem here. So it says Jason's financial portfolio had performed well over the past 6 months. His valuation in January was $275,000. It was $300,000 after 3 months, and the valuation was $310,000 at the end of June. What was the percent increase of his financial portfolio from January to June? So we are looking for the percent increase from January to June. Now these are two very important words to us here because January and June give us a starting point and an ending point. All right. So what we're going to do is we only want to concentrate on the numbers that deal with January and June. All right. It says that the valuation in January was $275,000. And the valuation was $310,000 at the end of June. Basically, the point being here, this $300,000 after 3 months, not important to us. We're not really worried about that. We just want to know what was the percent increase from January to June. So those are the two values that we're going to be concerned with. So if you turn to page 542 in the book, you'll see a green box there that kind of defines how we find a percent increase or decrease. All right, and I wrote that out here. It's kind of a two-step process. So you first want to subtract your smaller number from your larger number to figure out how much of an increase or decrease there was. So it looks like my June number disappeared on me. Let's write that back in. So that's going to be too small. So June, that is $310,000. Okay. So the first step of our process here, guys, remember, is to subtract the smaller value from our larger value to figure out the amount that we increased or decreased. So remember, we are going from January to June, and our number is growing. So in this particular case, we're going to be looking at an increase. Let's see what exactly that increase is. Let's open up our calculator. So we're going to subtract the smaller from the larger. So we take our larger, 310,000, and subtract from it the smaller, 275,000. So that means we have a $35,000 increase. So our increase is $35,000. Okay. So now, the second step in our process, once we have found the amount that we increased or decreased, remember in this case it was an increase, it says find out what percent the amount, meaning this amount, of increase or decrease is of the original amount. So we want to know what we started with. This is our original amount, right? We started with $275. We increased to $310,000. So that is a difference of $35,000. So what percent is $35,000 of $275,000? All right. So what we need to do is we need to set up ourselves a proportion. So basically we have $275,000. All right, that was the total amount of money that we had at the beginning of this entire process, meaning that is representative of 100% of all the money we had. Well, if $275,000 is representative of 100% of our money, then I wonder what percent of our money would $35,000 be? What percent? X percent. So if $275,000 is 100%, then $35,000 will be X percent, some unknown percent. And now we have our proportion here set up, so now we just need to solve. So remember, whenever you set up a proportion or you have two fractions set equal to one another, we're going to cross multiply. So let's take 275,000 times x. That's going to be 275,000x. And we're going to set this equal to, and of course I'm running out of room. We'll make it work. I might have to type this one in though. So we have 35,000 times 100. So basically we just have 35,000 and we add 2 zeros to it. I'm going to kind of cheat here. I want to make this a little bit bigger though. So this is equal to, so we have 35,000, but we're multiplying by 100, so we need to add 2 more zeros, which turns into 3,500,000. So we have our equation here written out, right? We just got done cross multiplying our proportion. Now we need to isolate that x. We want to get x all by itself. Oh, I forgot to hit enter. That's gonna be... All right, hold on one second here. So like I was saying, we need to isolate x. In this case, divide both sides by 275,000. Not the prettiest 275,000 ever. Divide this by 275,000. Okay, so dividing by 275,000 on the left is going to cancel out this multiplication of $275,000 with x. So all we're left with here is x equals, and now we'll get out our trusty calculator and figure out what that is. So 3,500,000 divided by 275,000 equals. So we have 12.72, and it appears that that would be repeating. So that means that $35,000 is 12.72 repeating percent of our original amount. So 12.72% would be our answer here. Alright, so the third and final problem that we're going to take a look at here, guys, is actually the very next problem, number 29. It says, scientists examined the nutritional content of a 12-ounce can of soda to determine the amount of sugar it contained. If the can of soda was found to be 75% sugar, how many ounces of sugar did the can contain? So remember, guys, in these word problems, it's always good to look for the question to see what it is that we're trying to answer. And in this case, we want to know how many ounces of sugar were in the can based on the information that we were given. All right, well, we were told here that we had a 12-ounce can of soda, which is 75% sugar. All right, so we know that there are 12 ounces, all right, of whatever in the entire can. So there are 12 ounces in 100% of the can. So this is 100% of the contents. All right. So if 12 ounces is 100% of the contents, then how many ounces are 75% of the contents? Because we know that 75% of the contents are sugar. So that'll tell us how many ounces are pure sugar. So we need to cross multiply first. So 100 times x is 100x. 12 times 75 is 900. Now divide both sides by 100 to isolate x. We divide by 100, we get 9. Do not forget your units.